Hello, welcome to 20SF Factory channel. Today I will show you how I rendered 4 pictures of my STL files on Blender. First, some of the STL files need to be downloaded from Thingiverse first. I go to thingiverse.com, search for Lego Man, which is the figure that I need. The first result came out okay, so I download it. And I also need a second part, which is the helmet for the Lego figure. So I search for Lego helmet on Thingiverse. This picture came out okay, so I download all the files that I need. And then I go to Blender, press X to delete the default object. First, I press Shift A, Mesh, Plane, which forms the ground of the STL files that I'll place on for the rendering. On this plane, using the plane as the ground of my STL files, I don't want a simple color. I don't want a simple gray. I want it to be an actual picture that I have. With the plane highlighted, I can press Tab to edit the corner point of the plane. So I choose the 2 dots, and then I'll press G to move the shape, and then press Y to move the shape in the Y-axis only. So this way I can drag the shape from a square into a rectangle. Using the plane as the ground of my STL files, I don't want a simple color. I don't want a simple gray. I want it to be an actual picture that I have. So I go to that red circle on the bar down there, which is the material property. I click New, and out of the default settings, I click the little yellow dot on the left and choose Image Texture, and then I would find the image that I need and load it onto the plane. After loading, we don't see the image right away because the viewport mode is now in solid mode, which is the solid circle on the top right corner. We need to change that into material mode by clicking into the semi-full circle. Turns out the shape of the plane is not oriented in the right way, so we use the same method, Tab, and then select the dots, and then we change the shape of the rectangle to fit the picture that we have. Now it is time to import some of the STL files that we have into the Blender workspace. We click File, Import, STL file, and then choose the ones we need. I will now import the robot parts that I have. They're not downloaded from Thingiverse earlier. The robot files are based on the STL files of the Community Robot Arm project. Some of the pre-processing has already been done. The link to the STL files are included in the description of the video. Now I need to move the STL file. I can move it around by pressing G and then the axis to move along, which is C. And then GX, GY. Besides the base, there are a few more robot parts we need to load in. So again, File, Import, STL, and we choose the file to be imported into the workspace. These are several STL files for robot parts. We will need to drag them together and assign different colors to each one to make the rendering nice. The following actions to align a robot are done using G button on the keyboard, together with the axis, which is X. After the robot parts are aligned, we select one of the several STLs to assign specific colors. Here, the screws and bearings. Select Material Property, and then press New. On the color plate, we pick the color we want. Underneath, there are many more properties that we can choose. Since we're working with screws, I'll choose Metallic setting and set the highest value. This will give a nice reflective surface in rendering. And we do the same step for the remaining STL parts. Now it is time to import the STL files of the Lego Man and the helmet that we downloaded in the beginning of the video. Normally the STL files on Thingiverse or the ones we generate for our 3D printers are measured in millimeters, but the Blender workspace is measured in meters. Imported STL files will always be way bigger than the intended workspace. It is translating millimeter into meter values. But for now, we'll import the rest of the STL files and adjust all of them before we scale them down in one go. So here one of the STL files are oriented in the wrong direction. We can press R on the keyboard to rotate it and then press the axis, in this case which is X, to rotate it along the axis into the orientation that we want. I'll be doing the same for the other Lego figure parts. Once again, we use the letter G and then the axis, which is X, Y, or Z, to move it around, and then we use button R to rotate it and rotate it along axis, pressing X, Y, or Z. We're almost done here. We can now select the parts that we want to color, which is the hand and the head of the Lego figure. We'll put those in yellow. Same as the robot we worked on earlier, we choose Material Property, New, and select the color from the color plate. We can call this Lego Yellow, so we can reuse this color in other objects later on. We click the next hand. This time we don't need to press New because we already saved the Lego Yellow color. So we just have to open the drop-down list and pick Lego Yellow. We follow the same procedure to have the remaining parts of the Lego figure colored. Remember we have a big plane of map earlier? Now we need to highlight the entire Lego figure, press S, and then move the mouse to the left side to scale it down until the size is right again. We use the same tricks of button G and button R to get the Lego figure into position. Oh, I think the Lego figure has a helmet, so let's repeat the step for the Lego helmet. We can highlight the robot together with the Lego figure and press R, and then this time axis Z to rotate it into the position that we want. I just found a new world map and I'm going to use the new one. It's more cyber, isn't it? This actual robot and the Lego figure is currently in New Zealand, so I'm going to drag it into New Zealand on the world map. If you follow the work of Robot Arm Community on Facebook, you'll know what I mean. Once again, a lot of G's, a lot of R's to get the robot into position. I have another robot arm which is completed in another Blender project, and I want to import that into this Blender workspace by pressing File, Append, pick the Blender file, select Collection, and then choose the collection that had the object stored. I'll highlight and press X and delete the objects that I don't need. And for the ones that I need, I'll drag them into position the same way I did with the New Zealand Lego robot. I'll scale down the map so the two robots can appear closer to each other. To render an image, we need to have an access to a camera view. A camera view is a virtual camera that points to your workspace, acts as an eye to look inside your workspace so the rendering engine can produce the image or the animation that you want. First step, in the middle black column, press View, and then check the box Camera to View. You understand it all. In the list on the top right of your screen, find Camera, highlight it. We can play with the settings later on. We can press 0 on your number pad to snap the viewpoint in the perspective of the camera. Because in the checkbox we lock Camera to View, we can now zoom around the screen in the perspective of the camera. So far we have been viewing our screen in material preview mode. We can start a preview in render mode to get a simplified glimpse of rendered results on screen. Here we click Render Properties. We can raise the render value. In this case, we'll raise it to 128 to improve the end result quality of the render image. There are two types of render engines. One is EV, which is faster but less complex. We'll use Cycles, which is the more complicated ones, taking more computing power. So we choose render engine as Cycles and device to be GPU compute. Right now the lighting seems to be shining not bright enough and it's shining in the wrong direction. We can change that. By zooming out of the screen, we can find the icon of the virtual light. There it is. We can select it and then press G to move it around the same way we moved with STL files. With the light object selected, we can go into Object Data Properties, which is the green light bulb button on the column of icons. Then we can adjust the power of the light source. The more the wattage, the brighter the scene will be. We're almost done with all the settings. One last bit is to highlight the camera, click the Output Properties icon, and change the size of the resolution X in pixels and resolution Y in pixels. It can be a square, it can be a portrait, it can be landscape. Pick the right resolution of your design. I'm happy with my setting, so I'll press F12 on my keyboard to begin the rendering. Normally on a regular laptop it would take 1 or a few minutes to render a single image. So I've rendered the image and I'll save it into my computer. We can play with the camera focal length as well to achieve the effect that you want in your image. With the camera highlighted, we go into Object Data Properties, which is the green camera icon on the icon column. We can now slide around the focal length and view the simulated result on the workspace. Once we're done, we press F12 on the keyboard again to begin rendering. And we follow the same steps to generate the last picture. And that's pretty much it. Whew, thank you very much for watching my first tutorial on YouTube. Thank you for your time. Please like and subscribe to my channel 20SF Factory and follow the work of Facebook Robot Arm community and see some of the awesome robots work that we're doing. Thank you very much. Have a nice day.